Guys, recording the vodcast solution for homework 5.1. This is coming from the 2003 AP test. Before we start this, I just want to let you know, don't do part F here. Okay, I can't get this in 10 minutes, and I don't want to have to record 2 vodcasts. Okay, so this is homework 5.1, and it's coming from the 2003 AP examination. We are on free response problem number 1. So we're going to start off by writing our script right away. So in this problem, they're asking, well, we're not even going to look. So K equals H2 times I2 to the first power over HI squared. These powers are coming from the coefficients. It's products over reactants. We're going to write our ice table. 2HI, arrow, arrow, H2 plus I2. Everybody counts. Question mark, 0, 0. Minus 2x, x, x. Question mark minus 2x equals box. X equals box. X equals box. The whole goal is to get these boxes, which represent the equilibrium concentrations, and plug them in to the K statement. So let's go through and see how much of this we can get. Okay, so let's look for initial concentrations first. We know that these are 0. The problem says after 1 mole sample of HI is placed into an evacuated 1 liter container. That is the initial concentration. And on this graph, at time 0, we have 1 as well. 1 divided by 1 is 1 mole per liter. So the concentration here initially for HI is 1. This is 1 as well. Okay? The reaction represented above occurs. That is change. We denoted that right here, and it really reaches equilibrium. Let's go and see if we can find any equilibrium values. Nothing in the statement, but in the graph we see that at 0.8 the concentration of HI reaches equilibrium. Okay? It levels out, it does not change. So HI, because that's who the graph below refers to, is 0.8 at equilibrium. Okay? We are given no other information, but having that 0.8 allows us to solve for x, because 1 minus 2x is equal to 0.8, therefore x equals 0.1. So these values are now 0.1. We can then plug those in. 0.1 times 0.1 over 0.8 squared equals 0.0164K, and this is actually going to be Kc in this case. Okay, so let's go through and let's answer the questions. A, write the expression for the equilibrium constant Kc. Okay, we already did that. That's right there. Great. What is HI at equilibrium? Go to your ice chart to find this information. Well, here is HI. They're not asking about I, C, but they are asking about E. It's 0.8. 0.8 moles per liter. Okay. Determine the equilibrium concentrations of H2 and I2. Always go to the ice chart every single time. So I go back, H2, I2, they're not asking for initial, they're not asking for change, they're asking for equilibrium. So for H2 at equilibrium it's 0.1, and for I2 at equilibrium it's 0.1. Okay? So this is 0.1 molar, and this is 0.1 molar. On the graph above, make a sketch that shows how the concentration of I2 changes as a function of time. H2. Okay, so we always are going to look on our ice table. Here we go. H2. Initially, it's at 0. So, initially, 0. It changes, it increases because this is a plus x, and it goes to 0.1. There's 0.1 right there, and it levels out. That's great because here's the reactant coming to equilibrium, here is the product coming to equilibrium. And we know that because the reactant is higher up here, it's reactant heavy. Okay, and this graph is really showing that it's reactant heavy because there's the reactants up there and there's the products down there. Okay, so here we're going to say C graph. Calculate the value of the following at 700 Kelvin. Okay, we calculated Kc initially. There it was, 0.016. 0.016, no problem. They want Kp. Okay, well there's an equation that relates Kc to Kp, and we'll be talking about this a little bit more in class. If you go to the equation sheet that I have connected to part 1, you'll see that there's the equation. Kp equals Kc RT to the power of delta N, where delta N is the change in moles product minus moles reactant. Okay, I'll label this out for you right now. Just to make things easier when we do this, let's write the equation first. Kp equals Kc RT delta N. Okay, 0.016 R is 8.314 multiplied by T, which is 700. Delta N, change in moles. So our reaction was 2HI gas goes to H2 gas plus I2 gas. So delta N equals moles of product gas minus moles of reactant gas. Product, 1 plus 1 is 2. Reactant, 2. That equals 0. So this is to the 0 power. So anything to the 0 power is 1. So this equals 0.06 times 1, which equals 0.06016. So in this case, Kc equals Kp. Okay. So let's look at this problem again. Notice, by doing the ice table out initially, okay, and filling it in, we were able to get not only the initial concentration of HI right here, we were able to get the equilibrium concentration of HI right here, which allowed us to plug that in here and solve for X. Solving for X allowed us to get the initial concentrations, equilibrium concentrations of H2 and I2. This then allowed us to solve for K, and subsequently we answered every single problem except for this and except for using this equation, which is nothing more than plugging into an equation. Okay guys, see you on Friday. Take care.